Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna talk about fluid. We're gonna explore what actually makes fluid interesting. So you got to think about like a fluid motivation. So what really can control the fluid? We know that with fluid, you can control it. It's by default. It's being controlled by the gravity. Fluid simply just being emitted um, using its emitter, the inflow, and then the fluid will fall and it's gonna hit the floor, gonna hit the wall. So that's the basic of the fluid. But what else? What else can control the fluid? Of course, obstacles and let's see like the basic things we can do using obstacles. But this is also kind of interesting when we start using procedural method. I will be using animation nodes once again. So yeah, let's get started. So we have this fluid domain, right? I'm gonna just save it. This is fluid domain. Let's assign fluid objects, and this is gonna be the domain. And we need some kind of fluid, and for that I will be using, I'm just gonna be duplicating this domain, and I will scale it down a little bit. So that's gonna be our fluid, and just gonna drop it there. And I'm gonna assign fluid. So that's gonna be the fluid. And if I just bake it, so we got a very static fluid. So it's just gonna drop inside the domain. Very subtle, very quiet. It's doing nothing. It's rippling a little bit. But let's see if we have some kind of cube, right? And what if we are controlling the cube? So let's see. Let's switch on animation nodes, object transform output, select our object, enable the location, combine vector, and let's see if we are just kind of pushing it in Y direction, for example. We're gonna leave everything else as it is, but just the Y. So we're gonna drop it like that. The Y, we're gonna control the Y using maybe sine wave. So frame math, it's gonna be sine, and the output goes into the Y. But you will see this will go just that small amount. So I'm gonna multiply it 5. Now it goes further. Okay, and we can actually offset it a little bit. So vector math, and then just offset it in the Y maybe a little bit. So now it's kind of pushing. Oops, that's too much. Something like that. It's kind of pushing it, but it's too fast. So we're gonna assign another multiplier, 0.2. So this is kind of like what I was talking about. Like what is the motivation of the fluid? Is it gonna be like a wave, like a wave, like that, crashing into the beach? Normally, I think it should be looking something like that. It's gonna crash and then make a splash, maybe. But what's interesting is that with fluid, when you start using sound, like even just the sound of wave that you recorded at the ocean or the beach, and then you bring it home and use the sound as the motivation of the fluid, like a CG fluid, and it starts to make a little bit more sense. So let's just take it. Now hopefully it's doing something. Forgot. This guy should be assigned as fluid obstacles. And we might want to offset the time frame as well. something like that. Stop the caching, bake it again. So now you can see the fluid's doing its thing. A little bit fast, you can see the obstacles. It's going too fast and crashing, just crashing the water. And by default, it's always preview. We're gonna switch to final. Final is gonna be 65 resolution. You can go higher. But this is interesting because you start to see the fluid reacting into the obstacles, right? It's pretty basic, but it's kind of interesting because anytime you can perhaps scale this, change the obstacles a little bit. Go back to fluid, bake it again, maybe change the speed. This will crash into the water. Hopefully it's creating some kind of wave. We might need a bigger domain, things like that. It's kind of interesting. In fact, you can also do a lot of things. You can have multiple obstacles, but maybe you just want to rotate it. So combine ruler and use degree. What's the size of our? So let's scale it like that, and then rotate it in z-axis. Rotate it like that. Spinning, rotating. Let's see what we got at the moment. So it's very turbulent kind of fluid, but the fluid is interesting this way. So stop it, bake it again. Now you can see the fluid even more turbulent. Sometimes you just want to experiment and see what the fluid can do. See if you can also actually make like a kind of spiraling fluid like that. It's gonna be interesting. So yeah, if you have like a sound of wave, or maybe you have music, you can import the sound of the music and then look at the waveform of the music and then see if you can control. You can use this to control the fluid, to control the obstacles, and then so the fluid's gonna move based on the sound of music, and that becomes the motivations of the fluid. Okay, yeah, because animation nodes also have audio, sound, so sound input, evaluate sound, etc. Maybe I will try that in the next video, but you got the idea. So what is the motivation of the fluid? What control the fluid? Because we know that CG doesn't make sound, but you can take like a real sound, use it as the motivation of fluid. If you ever want to deal with fluid, sometimes you use it to control the fluid emission as well. Let's say you have multiple fluid emissions and then you're using the music, you control the fluid. So that can be kind of interesting to try. And for that kind of procedural thing, you can use something like animation nodes, because it works. See, you don't even need to keyframe, it's just gonna work like that. Alright, so hopefully you find this useful. Let me know what you think, and I'll see you next time. Thank you. Bye.